Hello everyone, welcome to my YouTube channel. Myself Gagan from Sri Venkateshwara College of Engineering. Today we are going to discuss about deterministic finite state machines. In this topic we are going to learn about introduction to deterministic finite state machines, definition and components of deterministic finite state machines, state and transaction in deterministic finite state machines, deterministic and versus non-deterministic finite state machines, and examples of deterministic finite state machines, and applications of deterministic finite state machines, designing of DFSM and implementing of DFSM, and conclusion of deterministic finite state machines. Next, we are going to learn about it. Introduction to deterministic finite state machine. A deterministic finite state machine is a mathematical model of computation. So it consists of a set of states and set of input symbols and set of transition functions and a start state. The DFSM inputs to determine whether the given input string is accepted or rejected. Next, we are going to learn about what is deterministic finite state machine and what are the components of deterministic finite state machines. A deterministic finite state machine is a mathematical model used to design and understand algorithms. So it consists of a finite set of states and finite set of input symbols and transaction function and initial state. A transaction function maps a state and input symbol to a next state. The deterministic nature makes it predictable and well defined. So what are the state and transactions in a deterministic finite state machines? State represents a condition or a situation in the system. Transaction signifies the changes from one state to another based upon input. Deterministic. Each state has a unique transaction for each input. Next, we will discuss about deterministic finite state machines versus non-deterministic finite state machines. So deterministic finite state machines have a single possible transaction for each symbols, so they are easy to design and easy to understand. So non-deterministic finite state machines can have a multiple possible transaction for each symbols, so they are more complex and more powerful than deterministic finite state machines. Next, we will discuss about what are the example for deterministic finite state machines, like vending machine and traffic light control and elevator control. So vending machines is a classic example for deterministic finite state machines, with the states of accepting money and selecting products and dispensing items. The next example is traffic light control. The control system of traffic light is a real-world application of deterministic finite state machines, with the states of green, yellow, and red lights. Elevator control. An elevator control system is another example for deterministic finite state machines, with the states for stopping, moving up, and moving down. Next, we will discuss about what are the applications of deterministic finite state machines, like software engineering, network protocols, and automated control systems and pattern recognition. So, software engineering used in Lexus, parsers, and code analyzers to process and validate the code syntax. Network protocols for implementing a protocol logic for data packet and routing and error handling in the network communication. Automated control system applied to smart grids and traffic control and industrial automation for efficient decision making. Pattern recognition, recognizing the pattern in images and signals used in image processing and signal analysis. Next, we will discuss about what are the advantages and limitations of deterministic finite state machines. The advantages of deterministic finite state machines are: the deterministic FSM are easier to design and understand due to their clear state transactions. The next one is they offer the predictable behavior and more suitable for real-time applications. The next are limitations. The limitations, they require large number of states to model complex systems and leading to increased complexity. So modifying transaction may require significant redesign and its the impacting system and flexibility. Next, in this page, we have discussed about how can we design a deterministic finite state machines. So identifying a system states. So determining all the possible states that can be in deterministic finite state machines. So according to the problem. To define transactions, specify the conditions for transactioning and between the states. Establish the initial states. Design the starting state of the machine and ending state of the machine. Next, in this page, we are going to discuss about the implementing a deterministic finite state machine. And implementing a deterministic finite state machine involves defining a state of transaction and initial state, the transaction functions and actions or outputs needed to specified for each state transaction. The implementation also involves designing the data structure and logic to execute a transaction. On data and side, here is example for I know how can we implementing a deterministic finite state machines. In this page, we will discuss about the final conclusion of deterministic finite state machines. So, understanding the DFA design, so clear structure and defined transactions, and implementing in a software, efficient handling of complex logic, real-world application, enhancing the security and validation process. So we conclude that it is evident that the deterministic finite state machines that provide a structured approach to modeling systems. From clear design, the principles to the practical software implementation and real-world applications. The benefits of DFS are far-reaching. Understanding these key takeaways, this enables seamless integrations of DFS and various domains. So thank you guys for watching this video. Please like, share and subscribe. So see you soon in the next video. Thank you.